In this video, we're going to go ahead and cover section 7.3, Multivariable Linear Systems. This is still part of Unit 7, Systems of Equations and Inequalities. Here we're going to talk about something you probably have not seen yet. It's called row echelon form, and we're still going to have that back substitution that we saw in the previous units. And basically what this is that we can rewrite a system. So we write an equivalent system so that the back substitution is possible. Okay, when you do have it in this row echelon form, which I'm going to show you in just a minute, it kind of looks like a step, like a staircase. And that's just the best way to describe it. Okay, so here we're going to start with an example that's already in row echelon form. And here's what it kind of looks like. Okay, you're going to have, and I have like a little diagram here. You're going to have an x, y, z in your top column, if it's a 3 by 3, because in other words, 3 variables, 3 equations. And the first term, your x, will have a leading coefficient of 1. So if that's done, then your first row is already in row echelon form. The second equation, again, if this isn't a 3 by 3 system, meaning 3 variables, 3 equations, will not have the x, and it's going to go straight into the y, where the y variable is going to have a leading coefficient of 1. And you can kind of see the step kind of happening like this, okay, like an upside down staircase. Okay, the last equation will be, well, your z, and if you follow this pattern, you see how it kind of does like a step looking thing here. Okay, and of course this one's also going to have a leading coefficient of 1. So the way it works is that if you have the z value, if you know what z is equal to, all you have to do is plug it into the second equation, solve for y, and then you know what y is equal to. And since you know z and y, you can plug them into the first equation and you can figure out what x is. Okay, and that's how this row echelon form works. Okay, so what we're going to do is we're going to look at an example that's already in row echelon form. And I'm going to show you again this little staircase looking deal we have here. We have like a step like this. You can see that the coefficient for x is 1, the coefficient for y is 1, and the coefficient for z is also 1. Okay, so let's go ahead and just solve this one. Like I said, this one's already in row echelon form, so we can just go ahead and solve it. If z is equal to 3, okay, then I'm going to plug in, let's see, we'll put it this way. We're going to plug in z equals 3 into equation 2, which is this one. So y plus 3z is equal to 6. We're going to plug in that 3 into my z, okay, which gives us 3 plus 3 times 3 is 9. Okay, we just solve. So minus 9 to both sides. So y is equal to negative 3. Okay, so now from here, we can plug in y equals negative 3 and z equals 3, because we already have that one, okay, into equation 1, which is going to be this one up here, x minus y plus 5z equals 22. Okay, and we just plug them in. So x minus parentheses negative 3 plus 5 parentheses 3 is equal to 22. And we just solve that, which is going to give us x plus 3 plus 15 equals 22. We move this down a little bit. And that's going to give us x plus 18 equals 22. Oh, that's supposed to be an x. Subtract 18 from both sides. So x is equal to 4. And of course, you would want to check this. We're not going to check these because there are quite a few examples. So you're just going to have to take my word for it. And if I do make a mistake, if you catch a mistake, by all means, let me know. But yeah, basically, this is it. So once you have your 3 answers, so there's my 3 answers, okay, you would write the solution like so. You want to put it in order x, y, z. Okay, so it would be 4, comma, negative 3, comma, 3. My x equals 4, my y equals -3, and my z is equal to 3. And that's it. And just in case you're curious on what this looks like, because we don't really have a z-axis, right? It's a three-dimensional. So you're thinking x, y, and then if there were to be an axis sticking straight out of the paper, I'm going to kind of pretend this is a 3D line, z, it'd be kind of like sticking out this way, like where my pen is. That would be where the point is located. So it would be 4, -3, and then out 3 this way. Kind of weird, huh? But don't worry about the graph too much. We're not going to focus on that. Just kind of a little bit of inside information. But that's it for this one. Okay, so if you already have it in row echelon form, it's not that bad. It's just plugging numbers in. Okay. So how do we get to that point? Okay, because that's the real where the work comes in. So remember from one of the previous units that we talked about something called Gauss. I believe it was a graph, an exponential application. Okay, so there is this guy Gauss has another property here. Well, I don't want to say property, but it has another process called Gaussian elimination. And what this does is it gets systems and it makes them into row echelon form. So it's a process to get any 3 by 3 system, or actually any system, but we're gonna work with mostly 3 by 3s into that nice row echelon form where it makes it super easy to solve. Okay, so recall that two systems of equations are equivalent when they have the same solution set. So that's super important because we are going to be changing some things, but we're changing them by multiplying or doing these operations we're going to see in just a bit that are allowed with this process. Every change that we do is still going to produce an equivalent system. So that's super important. Even though we're changing some of the values, the whole equation as a whole is still going to have the same solution. So we're allowed to do that. Okay, so our goal is to get the system to look like a row echelon form like the one from before. Okay, so here's what's allowed. Okay, operations that produce equivalent systems. I'll try to get this all on the screen here. Each of these row operations on a system of linear equations produces an equivalent system. So we can interchange two equations, meaning if I want to put the one on the bottom on top, I can do that. You're allowed to do that. It doesn't change anything. We can also multiply one of the equations by a non-zero constant. And we saw this with the process of with the method of elimination. Okay, the 7.2 we did before this. So you can multiply an equation by any non-zero constant as long as it's the entire thing. Okay, and that includes fractions, so keep that in mind. We can also add a multiple of one equation to another equation to replace the latter equation. And this is where it gets a little bit tricky because if you don't keep track of what you're doing, it's super easy to get lost. Okay, so we're going to start with a really simple system here to show how this kind of works. Okay, and you can see this is a 2 by 2 system because we have, well, I don't want to say 2 by 2, but it has two variables, okay, and it has two equations. Okay, well, I'll try not to use that word because when it comes to matrices, it's a little bit different. I don't want to confuse you. So this has two variables, two equations. We'll leave it at that. Um, remember that for row echelon form, we want to have our top equation to start with a x that has a leading coefficient of 1. So the first thing I'm going to do for this one, okay, and I'm going to kind of try to write these out for this first example, is I'm going to interchange equation 1 and equation 2. Okay, so let's pretend this is our first one, this is our second one. So what that's going to do is it's going to put this one on top. So I'm going to have x plus 2y equals 3, and then 2x plus y equals 3. And this is our new system. And the reason I did that is because I want that x on the top because it has that leading coefficient of 1. Okay, so there's my first row operation. Next, okay, I can see that for this second one to be row echelon, I have to get rid of that 2x because if I have the y, you have that step that you wanted, okay? So to get rid of 2x, well, you would have to have a negative 2x, right? So we're going to use the third thing right here. We're going to add a multiple of one equation to another to replace the latter. And here's how this works, okay? I'm going to do this. I'm going to box up the system as we go. So this system is what we're using right now. This is equation 1. This is equation 2. Okay, so right here, I'm going to multiply equation 1, okay, by negative 2. Okay, so I'm going to multiply this by negative 2, and then I'm going to add to equation 2. Okay, so here's that operation. Let me use a different color for this part because it's like I said, this is where it gets a little bit tricky. So I'm going to multiply negative 2 times that top equation, so times x plus 2y equals 3, okay? And that gives me negative 2x, minus 4y. I messed up there. It's minus 4y equals negative 6, okay? And then I'm going to add to equation 2. So I have to bring equation 2 down here, and I'm going to add it to this guy right here. 2x plus y equals 3, like so. Okay, what this does is it's going to get rid of the x for me, and I'm left with negative 4y plus y is negative 3y equals negative 6, and 3 is negative 3. And then I can reduce this part. Okay, I can divide both sides by negative 3. So y is just going to be equal to 1. And this becomes my new, so let me make a note here. This is now equation 2. Okay, this is now equation 2. So after you do this, all this little row operation here, okay, the new system looks like this now. We have our, let me get this a little bit more, trying to get it all on the paper here. It's not that easy. All right, so our first equation is still the same. Even I know that we changed it over here, but the only reason we changed it here was to get rid of the 2 on the second equation. We're still keeping it for this purpose. So x plus 2y equals 3. We're keeping it from here, and we're going to use the equation that we found here for equation 2. So y equals 1. So this is now our system. Okay? So if you want to think of it in terms of like steps, okay? This was step 1 right here, where we interchange this part. This was step 2, where we multiplied equation 1 by negative 2, and we added that to equation 2 to get this y equals 1 over here, okay? Step number 3 is going to start here somewhere. So right here, we can put step 3, I guess. So step 3, this is our new system, okay? And once you have, and our new system is in row echelon form, new system, which is, okay, in row echelon form. Okay, so that means that we can solve. Okay, so from here, we're just going to solve for x and y, which would be our step 4 in this problem. Okay, I don't want to make the steps general because it depends on the problem. Some of them have a lot of steps, some of them just have a few. Okay, so from here, I already know what y is. Okay, so I'm just going to plug that into the other one. So x plus 2y equals 3. X plus 2 times 1, since y is equal to 1, equals 3. Okay, that gives me x plus 2 equals 3. Subtract 2 from both sides, so x is equal to 1. So there are my two answers, okay? The solution for this one is 1, comma 1. Now, I'm sure some of you are going to say, well, this is a system that we know how to solve, from using other methods. I could have used substitution, I could have used elimination, and for sure you could have, okay? But I wanted to start off with something basic because once we get to the next one, you're going to see that it's not as easy as elimination substitution, okay? So again, this part right here, this is where you see that step going on. I'm going to go ahead and highlight this one more time. This part right, this system, once we get to this part, after our row operations, okay, which is what we did up here, this is the place where you can start solving. So you do have to get that 1x, 1y, okay? All right, so we probably will do some of these in class because I know that these are difficult. So let's go ahead and look at another example. We do have about 6 examples. So we'll see if we can get it all in one video. If not, we might have to split it up. Okay, so in this example, we have 3 variables, x, y, and z, and we have 3 equations. Okay, so we can kind of think of it as a system that's going to have, well, a three equation system. Okay, so we are going to solve for x, for y, and for z. So I want to go ahead and start by identifying which of these equations I can use for my first equation. So this is 1, 2, and 3. This is the best way I can think of to identify equation 1, equation 2, equation 3. Okay, remember that for row echelon form, we want to have our first equation with a leading coefficient of 1 for the x. So it looks like this one does have that. This one has 1x, I guess you can say, as the leading term. So that's why I put a check mark. So we can actually leave this. We don't have to do any kind of switching like we did with the other one. Okay, it looks like our second equation has x, y, and then no z. Okay, so that's going to be a little weird, but we'll figure it out. And then this one has all 3. So let's try to get rid of this negative x here, because we know that for echelon form, the second equation has to have no x, and it goes right into the y and the z, right? So what we're going to do for our first row operation, and again, these you can do several different ways as long as you get to the same ending, okay? Right now, I'm trying to get rid of that negative x, because if I get rid of the negative x and I have a y, and then I can work with the 3 later, okay? So I'm going to add equation 1 plus equation 2. That's the operation that I'm going to do here, okay? So, and that's going to give me and this is going to give me equals, we can say like this, new equation 2. If that helps. Okay, so I'm going to take these two guys and add them right here. Trying to get this all on the screen here. So x minus 2y plus 3z equals 9. Negative x plus 3y, there's no z, is equal to negative 4. I'm going to add these two guys right here. So that's going to be, those are gone. Negative 2y plus 3y is positive y. 3z plus nothing is still 3z, so this one just comes straight down. Okay, 9 minus 4 is 5. So this is now my new equation 2. Okay, so here's what I'll try to do. I'll try to do the operation on this side, and I'll put the new system right here. That way you see what our system is as we're going. So again, this was our original system. This is the first operation I did. This is how I did it. And that's going to take place of this one. So now here we have x minus 2y plus 3z equals 9. So the first one stays the same. The second one is being replaced by this. So y plus 3z equals 5. Okay. And then my third equation, I haven't messed with that one yet. So 2x minus 5y plus 5z equals 17. Okay, and so now this is the system that I'm looking at. So again, this is equation 1, this is equation 2, this is equation 3. Okay, so far it looks like I have the step going on here. I'm okay with the first one, with the second one. I just have to fix the third one now. So for the third equation, I need to get rid of 2x and the 5 and the negative 5y, and I have to get rid of that 5. So to get rid of the x, I'm going to have to use equation 1 because equation 2 doesn't have any x's. So for my next row operation, here, let me label this right here. These are the row operations. Okay, so you have your stuff a little bit more organized. So for my second operation, I'm going to, for me to get rid of 2x, I need negative 2x, right? So the only way I can get negative 2x here is if I multiply equation 1 by negative 2. So that's the first thing I'm going to do. Then I'm going to add that to equation 3. Okay, so I'm going to multiply this one by negative 2 and then add it to this one to get rid of that negative 2x. Okay, so here's that operation. We have negative 2 times x minus 2y plus 3z equals 9. Okay, so I'm going to do this part first. So distribute, right? Which is negative 2x plus 4y minus 6z equals negative 18. Okay, so this is the multiplication part. And then I'm going to add this one to equation 3. So I'm going to add this part to equation 3. So 2x minus 5y plus 15z equals 17. Okay, so let me add that. That gives me the 0 I wanted. 4y minus 5y is negative y. Negative 6z plus 15z is going to give me positive 9z. And then negative 18 and 17 is negative 1. Okay, so yeah, be careful here because this was supposed to be a 5. I don't know where I got 15 from. See what I mean about handwriting, guys? Handwriting goes a long way. So yeah, so negative 6 plus 5 is negative 1. So that's why this one is negative z. Make sure you have that correct. All right, so this is now going to take place of our new equation 3. Okay, so this is our new equation 3. So I'm going to rewrite my system again. I'm going to keep these two, but instead of this one, I'm going to use this equation. So x minus 2y plus 3z is equal to 9. This is equation 1. Then we have y plus 3z is equal to 5. This is equation 2. And now we have this one, negative y minus z is equal to negative 1. And this is equation 3. So now this is our system. Okay, and you can see that we're almost there. We're almost there. We just have to fix this one now because now I have to get rid of that. I have to get rid of this guy, right? The negative y. And then I have to make that positive. So let's see how we're going to do that. If I add these two together, so if I put these two together, I'll get a 0 that way, right? And I'll be left with z. So let's do this. For our next row operation, we're going to add equation 2 and equation 3. Okay, so here's what that's going to look like. Y plus 3z equals 5, and this is going to equal our new equation 3. Okay, so y plus 3z equals 5. Negative y minus z equals negative 1. Okay, those guys are gone. 3z minus z is 2z. 5 minus 1 is 4. Okay, and then from here, you can actually solve this one, right? We don't have to, we can get rid of that too. So if you get something like this, you can always solve it if you can. Let's divide it both sides by 2. So z is going to be equal to 2, and this is now our new equation 3. Okay, and I think we're going to be okay after that. So let's go ahead and plug it in and see what happens. So we're going to rewrite our system one more time. And I know these take a while, guys. Like I said, this is where it starts getting a little bit interesting. So x minus 2y plus 3z is equal to 9. There's our first equation. Y plus 3z is equal to 5. There's our second equation. And our new equation 3 is now this guy right here. So z equals 2. And it looks like we have that step that we wanted. We also have our leading coefficients of 1. So 1x, 1y, 1z. So it looks like we are now in row echelon form. Okay, so at this point, and I forgot to keep putting this. You can keep putting it if you want. I usually just write it when I'm doing my operations, but that's all right. So at this point, we are in row echelon form. Yay. Okay, so now we can solve. So that this means we can now solve. So but to solve, we're gonna go ahead and do that back substitution to get the rest of them. If z is equal to 2, okay, so we know that oh, sorry, I don't know why I put not equal to. It's all those lines. Z is equal to 2. We're going to plug in to equation 2 to solve for y. Okay, so here's equation 2. Y plus 3z equals 5. So y plus 3 times 2 equals 5. 3 times 2 is 6. Subtract 6 from both sides. So y is equal to -1. Okay, so there's y. Now that we have y and z, okay, so we have y and z, we can plug both of them. So now plug both y equals -1 and z equals 2 into equation 1. Okay, so equation 1 was x minus 2y plus 3z is equal to 9. So now we have x minus 2 times -1 plus 3 times 2 equals 9, which gives us x plus 2 plus 6 is equal to 9. 2 plus 6 is 8. So I have x plus 8 equals 9. Now this is barely going to fit here, huh? Minus 8 on both sides. So x is equal to 1. And there is our solution. So solution, remember the solution has to be in order, x, y, z, which is going to be 1, -1, and 2. Word to the wise, guys. You do need to show work for these. These require work. There's no other way to do them unless you're going to just plug them in, and that's just not the way to do it, okay? So that's it for that example, okay? We're going to try a few more, but we're halfway done. There's 6 examples. So example number 4. Let me get this out of the way over here. Example number 4 is an example where you're going to have a no solution at the end, okay? So I'm going to go a little bit faster with this one because I think we need to not make the videos too long, right? So again, equation 1, 2, 3. I'm going to box it up. This is the one we're using right now. Let's see what row operation we want to do first. So we'll put our row operations over here. Row operations. Ooh, that's a little messy. That's all right. So it looks like we already have our first equation with the leading coefficient of 1. So we're going to leave equation 1 as is. I'm going to try to get rid of the second equation. So For the second equation, I have to get rid of that 3x, okay? So to get rid of 3x, we do negative 3x. So let me multiply equation 1 by negative 3, because that's what I have to do to get rid of this guy. Then we're going to add that to equation 2. Okay, so here is that operation. Negative 3 times all of this. So x plus y minus 2z equals 3. And I just distribute everything. Okay, so negative 3x minus 3y plus 6 times z is equal to negative 9. Okay, and now I'm going to add this one to equation 2. So let me bring equation 2 over here. 3x minus 2y plus 4z is equal to 1. Let's add these two up, which is going to give us that 0 that we wanted right here. Okay, negative 3y minus 2y is going to give us negative 5y. 6 and 4 is going to give us 10, 10z. And then 9 and 1 is also going to give us 10. Okay, I'm sorry, not 10. Negative 9 and 1 is going to give us negative 8. My bad. Okay, so now this becomes our new equation 2. So let's go ahead and write that in place of this one. We're going to put this one now. So here's my new system. X plus y minus 2z equals 3. My new equation 2 is the one I had over here. So negative 5y plus 10z equals negative 8. And I probably should have wrote this a little bit more this way. That's okay. My third equation is the same because I haven't done anything to it yet. 2x minus 3y plus 6z equals 8. Okay, and this is our new system that we're looking at now. So here's equation 1, equation 2, and equation 3. Okay, and it looks like the second equation is still not quite ready because we have that negative 5 in the front. So we want to get rid of that negative 5. So my next operation is still going to deal with equation 2. To get rid of negative 5, you can divide by negative 5, right? But when we do it with the row operations, we always say we're going to multiply by something. So if you're going to divide by negative 5, it's the same as multiplying by negative 1/5. Okay, so here's where the fractions start coming in. We're going to multiply equation 2 by negative 1/5. Okay, so let's see how that works. Negative 1/5 times equation 2. So negative 5y plus 10z is equal to negative 8. Okay, like so. Okay, so where we distribute this, we get negative 1/5 times negative 5 is going to give us just the y by itself. Okay, negative 1/5 times 10 is going to give us negative 2. If you need to do this operation on the side somewhere because you don't remember, that's perfectly fine. Okay, equals negative 1/5 times negative 8 is going to give us positive 8/5. Okay, so that's, I mean, we really can't do anything else past that. So now this one becomes our new equation 2. So this is now new equation 2. So let's go ahead and rewrite this again. So now we have, again, x plus y. I'm coming up with these numbers that are not even there. X minus y, so x plus y minus 2z is equal to 3. And then we have this guy now. So y minus 2z is equal to 8/5. So we get a fraction, okay? And the third equation, 2x minus 3y plus 6z is equal to 8. okay? And this is our new system that we're working with now. Remember, when I say new, I don't mean that it's I just mean it looks different, because really they're all equivalent because they do have the same solution set. So it's still it's it's the same in that respect. So don't get oh, my bad. Don't get confused with that. All right, so it looks like equation 1 is okay, equation 2 is okay. Now we got to deal with equation 3. We got to get rid of 2x and the 3y, okay? So we're going to do the same thing we did in the problem before. Get rid of that 2x, you have to do it times, you have to add it to negative 2x, right? So we're going to multiply equation 1 by negative 2, and then add to equation 3. So let's do that. Negative 2 times x plus y minus 2z is equal to 3. So I'm just recopying it. And then I distribute that negative 2 to everything. So negative 2x minus 2y plus 4z equals negative 6. Okay, so there's a multiplication. Now I'm going to add it to equation 3. So let's bring equation 3 over here, like so. Okay, let's add these up. That gets rid of that for me. Negative 2y minus 3y is negative 5y plus 10z equals negative 6 and 8 is 2. Okay, so this is now our new equation 3. And some of you are going to start seeing some ways to do a little bit of a shortcut for this, like going from here to the next step, but I won't talk about that. I'll let you figure it out. This becomes our new equation 3, so let's go ahead and rewrite it. X plus y minus 2z is equal to 3. Y minus 2z is equal to 8 over 5. And then negative 5y plus 10z is equal to 2. And again, equation 1, equation 2, and equation 3. Okay, so we still have a problem because we need to get rid of this, right? We've got to get rid of that negative 5. So let's go ahead and multiply this one times 5 and add it to this one to get rid of that. How about that? Because to get rid of negative 5, you have to have positive 5, right? So that's going to be our next row operation. We're going to multiply equation 2, okay, by 5, positive 5, okay, and then add that to equation 3. Oh, let's keep it capitalized. Equation 3. So here we go. This one times 5. Y minus 2z equals 8 over 5. Okay. 5 times all of this is 5y minus 10z equals, look what happens here. 5 times 8 is 40. 40 divided by 5 is 8. So yay, no more fractions. Okay. And we're going to add that to this guy. Well, no more fractions for this part anyway. So we're going to do this. I'm just copying it over. And you can see here, the y's are gone, but so are the z's. So we have 0 is equal to 8 and 2 is 10. So what happened here? Okay, so this is now our new, I guess you could say, equation. But the good news is that this is not going to work. This means that z has there's no value that's going to make this work for z, and z is a part of these other ones, so therefore that's not going to work either. Okay, so basically at this point what I would do is I would rewrite everything. So x plus y minus 2z equals 3. Y minus 2z is equal to 8 over 5. And I'm just using the same ones here. And this is my new equation 3, right? This is now equation 3 over here. And then 0 equals 10, which means there is no solution. All that work just to come up with that, okay? But you do have to be able to get to that point, okay? So I think I'm going to stop this video here and we'll cover the last two examples in a separate video because it's been a little bit lengthy. So I'll see you in a bit.